Alright guys and gals, let's go ahead and get started. So we are currently reviewing for our end of course assessment. Now there's no traditional EOC that the state's going to give us, but we are going to have a cumulative final. So what I've done is I've picked a couple of lessons throughout the year that I know you guys struggled on between me observing you, your quizzes, your tests, other things like that. And one of the lessons that I know that we definitely can improve on and that I want to expand on after I reflected this year is definitely the binomial theorem that we talked about this year, and more specifically how to use Pascal's triangle to do the binomial theorem. So the way that we learned this the first time was we took Pascal's triangle, and you guys discovered this on your own, and now I'm just showing it to you so that we can use it, because like I said, we've already discovered it. And what we're going to do is we're going to use Pascal's triangle to expand this x plus y to the 6th power. And the way that we would do that is we would go to the 6th row, because of the exponent right here, of Pascal's triangle. All right? And I know some of you guys struggled with this during the actual chapter of this, because you were thinking that this top row right here where my pen is, you were thinking that that's the first row. And that's the biggest misconception of this Pascal's triangle, is that where my pen is right now is not actually the first row. It's what's called the 0th row. It doesn't technically count. It's when something is raised to the 0 power. And we all know that anything to the 0 power is 1. So instead of this is the 0th row, this is the first row. Okay? This is the 2nd row, 3rd row, 4th row, 5th row, 6th row. So we need to be using this row right here, and that's going to be our coefficients for our final polynomial after we expand this parentheses. Okay? So I need you to take out your Pascal's triangle, and I need you to follow along with me. Okay? And what we're going to do, the way I showed you guys how to do this, is we're going to take the coefficients that the triangle gives us, which is 1, 6, 15. Now notice how I leave a little room in between the numbers. Okay? Any idea why I leave a little bit of room in between the numbers? Okay, good. Yeah, definitely. It's because there's going to be other things besides numbers. We're going to have to put in x's. We're going to have to put in y's. We're going to have to put in plus or minuses. It gets a little tricky. Okay? So, and then Pascal's triangle, the 6th row, also has a 20. Okay? And I'm going to skip down a row. If you guys have enough room to do it all on one line, that's perfectly fine. But I'm going to skip down below this 1 right here and put the next number of the polynomial, which is 15, and then 6, and then 1. Okay? So there's the coefficients to my new polynomial. And what we're going to do now is we're going to take this term right here, and we're going to start off, with x to the 6th power. Okay? And does anybody remember where we go from here? Is this content coming back to any of you guys? Okay? The powers decrease as we go to the right for the x. So we're going to have x to the 6th, x to the 5th, x to the 4th, x to the 3rd, x squared, okay, x to the 1st, and then this one is technically x to the 0 power, and we've all agreed already that anything to the 0 power is good, 1. Now, we're done with the x's, so what we're going to do is we're going to take the second term, what's on the right over here, and that includes this plus sign, so please do not forget that this is plus y. It makes a difference down here if you look at my next example. Okay? We're going to take that and we're going to go backwards. So instead of starting with 1x to the 6th, we're going to start down here and we're going to put 1y to the 6th. All right? And we're going to do the same thing except backwards. All right? And then this right here would be y to the good. Okay? Now let's do the symbols. Well, since this is x plus y, it's pretty logical that all the symbols in between here are going to be positive. So we're adding all of these terms together. Let's put a plus in front of the 15 so we don't forget. Good. And then plus 1. All right. What's going to get a little trickier is when we get down here to this x minus 4 to the 5th power. See how this negative right here, or this minus 4? That's definitely going to throw a wrench in things. And that's going to make maybe some of these signs up here plus or minus. Some of them might be negative, some of them might be positive. We don't know. We will know soon. All right. So first of all, let's find out, do we have any like terms? So do we have anything that we can condense? All right. I don't think so. So we're going to stop right there. That is our final answer to this problem. Okay. Now let's move on. Here, it's going to be a little trickier. Instead of using the 6th row of Pascal's triangle, we're actually going to use the 5th row. Good. All right, so let's find those coefficients. 1, 5, 10, 10, 5, and positive 1. Okay, wonderful. And now what we've got to do is